Hey everyone, in today's video we're going to talk briefly about some applications of similar triangles. Recall that similar triangles are very useful when you know information about one triangle. You know that there's a second triangle that is similar to it, which means that the three angles are the same, and you're looking for a piece of information about that second triangle. Let's start off with a very classic example of two trees. So two trees cast shadows as shown. How tall is the evergreen tree? So first and foremost, we know that this tree on the right is our evergreen tree, and we are looking for the height. We know that its shadow is 8 meters long. We also have another similar tree here. It is 14 meters tall, and its shadow is 5 meters long. These are similar triangles because you can imagine the sun is somewhere up here and it's shooting down. It's creating the same angle to both trees, except one tree is just taller than the next one. Let's start off, and I'm going to start off by reminding myself that this side is what I am looking for. That is going to be my x. Let's just move me out of the way here. Okay, that's going to be my x. I'm very first and foremost, I'm going to start by matching my sides just like we had done previously. So I'm going to say the height of the triangle is going to be the red side, and we can see that the heights are similar. We'll do the shadow as green. The shadow has to be similar. And we can fill it in. We don't really need this dotted line, but we'll fill it in just to finish off drawing our right-hand triangle. Okay? Using this information and the fact that they're matched up, we can now find our scale factor. So in order to find the scale factor, I'll do this in blue. So our scale factor is going to be, in this case, 8 divided by 5. I got that because the green side is the only side of my triangle that I have information from both triangles, the small and the large. And just like we find scale factors, we do big divided by small, 8 divided by 5. So in this case, 8 divided by 5. And we can go ahead and we can do 8 divided by 5, which is 1.6. Now that I know I have a scale factor of 1.6, I can start up with my similarity statements. I am looking for information from my large triangle, which means I start from my small to large. I'm going to say, okay, that means 5 and 8 have to be similar. And in the same way, 14 and x have to be similar. How are they similar? Well, because we're going from small to large, we're multiplying, and we're multiplying by our scale factor of 1.6. If I do that on my calculator, 5 times 1.6 gives me 8. So now I know I can do 14 times 1.6, and that gives me x is equal to 22.4. And there's your answer. The height of the evergreen is 22.4 meters. Let's scroll down and let's do our next example. You live in an A-frame house. An A-frame house is a house that is shaped like this, where it basically has one giant roof. The width of the second floor is 25 meters. The width of the entire house is 75 meters. You know that the length of the roofing from the peak of the house to the second floor is 12 meters. How far is the peak to the ground? Okay, let's start by labeling our diagram with some of the information that we were provided with here. I was told that the width of the entire house is 75 meters. I was also told that the width of the second floor is 25 meters. I was told that the length of roofing from the tip of the house down to the second floor was 12 meters. Okay. I am looking for how tall is the peak to the ground. We very clearly have two triangles here. Okay, I have my small triangle I'm just going to redraw. So I have this side is 12 and this side is 25. And I also have a second, much more larger triangle where my bottom is 75 and I am looking for the total length. Okay. Knowing this information, I'm just going to erase these. We are going to start immediately. We are going to find our scale factor. So our scale factor, we're going to use the two sides that we have, the 25 and the 75. 25 and 75. Okay, I'm just going to redraw our triangles over here. Okay, just like we've done previously, we're going to start by matching up our side lengths. I know that the two bottom side lengths, those are a pretty easy match. I have two horizontal or diagonal side lengths. Those are a pretty easy match. And let's do the last one here just to finish it off. I now need to find my scale factor. The only information that I have for both triangles is the bottom level. So I have 75 and 25. And I'm going to do 75 divided by 25, which is just 3. So my scale factor is 3. Now I can set up my similarity statements. So I can say, okay, I need the information for my large triangle, which means I'm going from small to large. That means I'm going to go from 25 to 75. And similarly, I'm going to go from 12 all the way to x. These sides are similar. How are they similar? Well, we have to multiply by our scale factor, which is 3. Multiply by 3. There we go. We know that 25 times 3 is 75, and therefore 12 times 3 is going to be x. So x is equal to 36. We could write a therefore statement to finish if you wanted. So the question was asking, how far is the peak to the ground? Well, the peak to the ground is a total of 36 meters. Let's do one last example. The flagpole casts a shadow 14.5 meters long at the same time that a person 1.8 meters tall casts a shadow 2.5 meters long. Find the height of the flagpole. Okay, we were not provided a diagram here, so let's go ahead and draw one. I know that I have a person standing, and I have their shadow. At the same time, I have a flagpole and the flagpole's shadow. We were given information that the flagpole's shadow is 14.5 meters long. We were also given that a person is 1.8 meters tall, and their shadow is 2.5 meters long. We are looking to find the height of the flagpole. Okay, that's pretty straightforward. Let's go ahead and let's finish off our triangles and draw some matching lines. I'm going to start off with knowing that the shadows have to match up, so they are similar. I also know that the heights of the two have to be similar. And finally, just to connect the dots, I have my third side of my triangle, which also has to be similar. Now that I've drawn those, I can find my scale factor. My scale factor, I'm going to be using 14.5 divided by 2.5. Those are the only sides that both had a piece of information because it was the red side. Both of them had that. They had the length. And I'm going to divide big by large. 14.5 divided by 2.5 gives me 5.8. So my scale factor is 5.8. Now I need to find the height of the flagpole. So I'm going to write my similarity statements. I'm going to go from small to large. My first statement, I know that I can go from 2.5 to 14.5. These are similar in that I multiply by 5.8. And in the same way, I can use the height of the person in order to find the height of the flagpole. These have to be similar as well, and I also have to multiply by 5.8. 1.8 times 5.8 gives me 10.44. So therefore, x is equal to 10.44. We can finish off with a therefore statement. Therefore, the height of the flagpole is 10.44 meters. Okay? So as you can see, applications with similar triangles are not that difficult. It's just a matter of making sure you have a solid diagram, that you understand the question, and that you really take the time to follow the steps like we have before when looking for an unknown side. Good work, everybody.